Hi everyone, and welcome to a TidalCycles video. This is, as usual, a little different than everything we've done before. This is, so I'm doing this zfest, like art and music intensive this month, and my composer partner on one of the projects was telling me about some ideas of how to relate sort of the mathematical structure in music in ways that might be amenable to programming and patterns. And so one of the things he talked about was the idea of having a sort of like a circular structure where like you take a set of musical ideas, kind of arrange, think of them as like points on a circle, and like you follow the circle to reach each of them, but then like the next iteration you actually like rotate the circle in terms of like its starting point and then follow around again. So I was thinking about how to do things like that in Tidal, and so for example, if you are doing something that is if you're doing something that is just one cycle each patterns, I believe one of the easiest ways to do that is to basically use the iter function, right? So what you do is you take a list of things, you take a list of things, and then you concatenate that together. You use iter to sort of properly do the kind of rotation type structure, and then you slow it back down to like the length of the list to sort of expand it back out. And so that should work, because if we think of this as like being points on a circle, then this should be what should basically happen is you should get, it should go 4 bass drums, 8 glitches, 16 RPs, and then what should do on the second round, well then it should start here and then be 8 glitches, 16 RPs, 4 bass drums, and then the time after that should start here and then be 16 RPs, 4 bass drums, then 8 glitches, and then back to the beginning. And so what we hear with this function definition is exactly that. So here. So yeah, you can hear that does the right thing there. What I kind of want, though, is something a little more general. And to do that, we're going to take, so this is again going to be, I haven't done this in a while, but it's going to be a video where we're basically live coding patterns, like live coding our functions. And the other sense of live and coding. So let's try this. We do so let's do a let's call it iter list. And we're going to make this slightly more general. We're going to have a skip distance, which we'll talk about in a second. In fact, we can always do an iter list prime and give it a skip distance, and then have iter lists just have a skip distance of 1. Okay, and then so this should take lists, and then return what do we want it to do? We want it to return, to eat a group of lists, and then return a pattern that cycles through a bunch of those operations of lists. Okay. So, to that end, I'm just going to look up one function quick, which is like, it's Fromlist. Oh, yeah. Let me see. There is a function for this. I'm trying to remember. Oh my goodness. Might actually have to. The new title documentation is good when it's good, but occasionally I find moments of being still a little sparse. I think it's something like Fromlist. Yeah. Let's just check what Fromlist does. Let's do a D1 of S and Fromlist, and then let's say BD CP SN. Okay. Let's see. Oh, right. Duh, of course. Okay. So what we want is, well, what do we want? In fact, here, it's I'm going to think for a second about what we want, because basically what we want is to take a list of things. I want to create permutations of that to like a big meta list. And then we want to turn that into a pattern. Okay. So, yeah, I don't think we want to do that. I think we want something like, let's say cat, because what does cat do? Cat takes a list of patterns and folds it into a pattern. Okay. Sort of preserving the original length of time of them. Rather than trying to force things into multiple So in that case we want cat of what? Okay, well, first off, if this is empty, then I mean there's just nothing. The pattern should just not be anything. So that's fine. Actually, is that gonna be right? So this is something I've gotten a little like twitchy about sometimes in Tidal is that rests are not, they're just gaps in events. They're not a lack of an, how do I put this? They're not a piece of data that says, don't put anything here. They're a lack of data. So sometimes they don't do things the way you think they should. Let's think about this. And, maybe I need to think about this a little differently. Okay. So if we were to let's just generate all the permutations of a list. And we can just do this in terms of skip distance too. Like, why not? Then, well, the first thing we need to do is like the ability to rotate a list. Let's have something like this. And say a list of n and l. Okay, well, if it's going to be 0, like if it's going to be an empty list, then we want to say it's an empty list, right? Okay. Then route list of n of x. So we're just doing a simple inductive data type here. And then actually we'll just say it as L, because we've already ruled out this empty list. Okay. So then we want to say let's take n of L. It's basically it's drop in of L. Then we put the take at the beginning. Okay. So let's just make sure this function works. So route list of 1 of 1, 2, 3 returns. If you probably can't see it because it's so tiny down there, but it returns 2, 3, 1. If I do 2, it gives 3, 1, 2, etc. Just kind of keep going. And then the problem is it doesn't, doing it this way doesn't quite work if you do larger than the size of the thing, but we'll figure that out later. It's sort of an obvious fix for that, but don't super know how much I care at the moment. Basically, you would just take the modulus, and I'll fix that off camera. It's fine. Okay, so now if we want all possible permutations through rotation, then what we want to do is okay, permutes it in now is okay. So this is where I'm going to do a list comprehension, which is it's an old school Haskell trick, but it's kind of a fun one. It's kind of a fun little trick. Just making sure I remember the syntax. Yes, I do. Cool. So then this will be L prime. Sorry. This will be rot list of n and n prime L for n. Let me see. Yeah. So I can can also do a guard. Yeah, okay, so n prime is an element of 0 to n. Let's just remind ourselves 0 to n does not include n. Oh my goodness. Buddy. What? Oh my goodness. Yes, alright. 0 to 10 does include 10. Okay, so this is actually what we want. We want to take oh, right. No, kind of messing this up. We want to rotate it by so if we say the skip distance is oh my goodness. Shoot. I'm trying to remember. Okay, that's actually what I want to do. M2. Okay. Or honestly, we could also just be super sassy and do this as the cut. Because let me see. Does that work? Let's see. We do h is equal to I don't know 100. Let me do the thing of h dot dot. Nope. Okay. Nope. Yeah, I know GHC. You're so cranky. Well, I mean, we proved that works. I may actually have to, like... Okay, sweetie, I'm sorry. I did not mean to give you, like, an infinite calculation. Just please forgive me. Yeah, I know. Okay, so... Reboot. Oh my goodness, I am so sorry. Okay. Oh no, that didn't actually do it. Oh no. Okay. Shoot. I'm going to have to like completely... how do I make just GHCI break? Just a second. I mean, this is kind of funny, but not really. Okay, it seems like I don't actually have any way of stopping this now because I accidentally set to an infinite calculation. So this is going to be like slightly weird with our recording because what I'm going to have to do, well, let's see if no, I don't think I have like literally any way to stop this. Okay. It's fine. It's all fine. Okay. So, here, we're actually just gonna close that. And then, so unfortunately we're gonna have a black screen for a second. Please don't panic. Don't panic. Again, asking you to not panic. Okay. There. And we're back. We're back and we're very sorry for what we've done. Okay. instead say this. Oh, right, of course. Oh, look. That worked fine. Okay. So now the other thing is that we want to do the condition that in prime is less than L. Okay. So that should work. Give a list of lists. Cool. So now, let's see if that compiles. Match expect type A. Huh. That's weird. Oh, this is just a... Actual type is secondary list L. Oh my goodness. Length of L. Okay, that compiles. Okay, so now let's try. So that should be properly guarded. So let's say permutes of 0, 1, 2, 3. Should return a list of lists. Which it doesn't because right. 1. And it gives 0 to 3. Okay, so that does what it should do. If I do 2, it also does the right thing. Oh, does it? Weird. It's also weird because it feels like it's not actually doing new things. Okay, nope. Something got in a rough state and I don't know why. Okay. So I don't know why the guard didn't work. Oh my goodness, it's not lazy. Okay. Close this down again. And so if you're still watching this, you're going to be learning way too much about what it's like when you try to get clever and haven't tried certain things in Haskell in like a super long time. Right, I forgot that's actually going to be going through this entire thing. So I really should have just said length of L here. Yeah, okay. So I will save that. I will close Atom again. I will reopen Atom. You poor thing. I will... Oh, good. It's immediately giving me the same. Okay. Now, let's try this again. Okay. Okay. So, we've just done the permutes function. Now let's try this. Aha! Cool. Let's try that. Okay. So now if we do permutes 2, I'll give us 0, 1, 2, 3, and then 2, 3, 0, 1, which makes sense because there's only 2 if you're just going back and forth. You say 3, you still get 2. They're just 2 sort of distinct ones, which I think is correct. You get the base 1 and then 1 more. Yes. Yeah, so those those things are correct. And if I say 4, think, yeah, it will just give me 1. Okay, so, modulo the need to modulo. That's basically right. Okay. So the important thing here is, so now we can take this, and so what do we do to take these things? And so if we have a list of patterns, so what we want to do is we don't want to take we want to take a list of patterns. We create all the permutations of the list of patterns. And then I think we have to do an internal cat and then an external cat. So I think we need something like iter list is going to be in and L. It's going to be cat dot map cat of mutes now. Think. Okay. I mean, it has the right type, and that gives you a general sense of how this should work. Okay, so in that case, iter list has the type we want. Takes list of patterns to a pattern. Now, so at the beginning of all this sassiness, we had this. So now the important part is, let's find out if iter list 1 of this gives the same thing. Okay, that's literally the same pattern, so that's what we want. So let's do 2, and so the skip distance 2 should create something kind of different. Cool. Yeah, that's working the way it's supposed to. Neat. Okay, so we've got this sort of general function for doing these rotations and turning it into lists of patterns with the cat function. And you have now watched me muddle through some of the finer points of Haskell programming for nearly a half hour. So I think I will leave this here and come back to it again tomorrow. So until then, take care.